Hey guys, I hope that all of you are doing well. We are going to wrap up some of the final derivatives and integrals of some special cases. So we're going to begin with Calculus 5.1 and the derivative of the natural log of x. This might be something that we've already kind of touched on, but I want to make sure that we go into detail on this so that way you do not have any loose ends for this exam. So the derivative of the natural log of x is simply 1 over x. Okay, so that's just something because whenever you're integrating 1 over x, that means that technically I would have x to the negative 1. And if I were integrating that, that would be x to the 0. And that's kind of undefined whenever you divide by 0. So this is one of the special cases that you're actually dealing with. If you have the derivative of the natural log of something besides just an x, as you can already look ahead in parts A, B, and C, and see that there's a little more complication to it, especially in A and B, then you actually have what's known as u prime over u, okay? And so you take the derivative of whatever the value is, and then you divide it by that value. In the very first term here, the derivative of the natural log of x, remember that the derivative of x is 1. That's why 1 over x also works. So for part A and I don't have this written in, but this is example number 3. So if you want to write that in, examples 1 and 2 in this lesson are simply review of what a natural log and a logarithm are. So if you need to go back, that's in your textbook on page 324 and 325. But I don't think that you'll necessarily need to go back to review that. This is the type of material that'll be on the exam. So the derivative of the natural log of 2x. So 2x is something where I can't just say 1 over 2x because the actual value of 2x is being represented as u. So I need to know that u is 2x, and then simply u prime is 2. So this simplifies to be u prime over u, which is 2 over 2x. And in this case, it does reduce to 1 over x. So if you ever have the derivative of the natural log of 2x, 3x, 4x, 5x, a coefficient times x, then you're going to end up with 1 over x as your answer, okay? For the second one, you're going to see as something a little more complex. Your u, in this case, will equal x squared plus 1, and u prime will equal 2x plus 0. And we're going to allow that plus 0 to be understood. So whenever I'm plugging this in, my u prime would be 2x over x squared plus 1. There's nothing more to simplify, so I leave it just like that. Okay. All right. The very last one, be careful on these because a lot of times you see this and you see natural log of x and you guys automatically assume that the derivative of the natural log of x is 1 over x. So x times 1 over x is 1. And then you simplify and that's the end of the problem. But do not forget here, you do have the product rule. Okay. I'm actually going to put this in a different color. Okay, so you will have x times the derivative of the natural log of x plus the derivative of x times the natural log of x. Okay, so as far as that goes, that would be x times 1 over x plus the derivative of x, which is 1, times the natural log of x. This will leave me with my final answer being 1, because my x is canceled, plus natural log of x. And that is my final answer for part C. Now on the next part, don't get too excited because there is a part D. Okay, and I put it on the second page because I ran out of time. Sorry about that. But whenever I'm looking at this, I am going to apply the chain rule. So I'm still taking the derivative of the carcass times the derivative of the guts. Okay, so my carcass is this 3 out here. Okay, this will end up being 3 times, and then I still have the natural log of x quantity squared. But then I have to take the derivative of the guts. Well, the guts in this case is natural log x. So when I take the derivative of that, it is 1 over x. This leaves me with the answer of 3 times natural log of x, quantity squared, all divided by x. Okay. If you have any questions, make sure that you see me or send me a text message or an email, and I'll be happy to explain these in detail. Thanks.